Boy beside Matthew, I don't know why you're holding your pants, covering your knee shorts. Can you pick him away your photo as well? I don't need it today. Okay, are we ready? Alright. Good morning, everyone. Morning. Have a seat, please. Okay, today we will continue with chapter 1.2. We're going to be looking at Venn diagrams. Okay, there are, I think you would have been exposed to Venn diagrams before already. Okay, maybe you have seen it in forms of memes and all that. Okay, so Venn diagram, Venn itself is actually I think a scientist or some person's name lah. Okay, it's a person's last name. Okay, so that's the reason why he invented the whole Venn diagram system. Okay, that's why it's called Venn diagrams. Okay, so a generic Venn diagram usually, okay, there is a rectangle or square, okay, to actually show the boundary of the universal set. So the universal set is being denoted by some letter, a Greek letter that looks like an E. Okay, so if you write it carefully, something like that. Okay, may not be the best in writing these letters. Right. So usually we label it at the top left-hand corner for the universal set. Okay, so this is supposed to denote the universal set. Okay. So sometimes we will define a universal set, okay, in order to scope it, okay, to actually know what exactly are we talking about. So let's say I can have a universal set of the class of 402 students, okay. Then after that, within the universal set itself, whatever that's inside, usually we will draw in circles. So the circles itself may or may not overlap, okay, or it will actually be one inside the other, or maybe overlapping in this manner, may also okay. It really depends on the situation, so there are many ways that the circles can actually be drawn. Okay, so we will actually label the circles. Okay, so usually we will label the set as capital letters. So let's start with something simple. So let's not do any overlaps first. Just give me one circle inside this. Okay, so we have one set A inside it. So for example, okay, if I have the universal set in this case, being defined to be, let's say, the numbers 1, 2, 3, 4, 5. Okay, then A itself, okay, is a set that maybe I define it to be equals to 1, 2, 3, containing the integers 1, 2, 3. Okay, the area that is outside the circle, right, okay, is what we call the complement set. So we will have a apostrophe on top, which actually we call it a prime. P-R-I-M-E. Okay. Okay, we read it as A prime, or you can read it as A complement. So this is actually what we call a complement set. Or complement of A. So in this particular example that I'm having, if A contains elements 1, 2, and 3, I will put in the elements inside of A. And then the complement of A are the things that are found inside the universal set but outside of A, and that will be 4 and 5. Okay. Venn diagrams actually works. Okay, but there are some points to note when it comes to the drawing of Venn diagrams. Okay, when putting in the elements itself, okay, we do not actually separate them out by using commas. Okay, so we don't use any commas, so I cannot write it as 4, 5. Okay, as much as you want to write it neatly, unfortunately, okay, we will have to space it out, okay, to be able to see clearly what are the elements. Okay, so don't write the elements too close together. Okay. Now, let's look at an example. Okay, so looking at practice now 3, that's in your textbook, page 7. Okay, we are given a universal set and a set B. Universal set are the integers between 1 and 13. B is the set of prime numbers. So all the sets that are actually being described, right? Okay, it is a part of the universal set. So the universal set sets the boundary for us. Okay, so when selecting the prime numbers, they are going to be inside the set B, right? Okay, it should not exceed 1 and 13. Okay, so it should not be outside of this range that is given over here. Okay, so the universal set is a boundary, right? So in order to list all the elements of the universal set and the set B in set notation, right? Okay, we will actually put it as 1, 2, 3, 4. All the way to 13. And then for the set B, okay, what are prime numbers? Let's find one person. I wrote all your names on my mistakes already. Bibi. Sorry, where's Bibi? Can you read out? 2, 3. Anything else? Okay, anything else? Sorry. 13, okay. Sorry, because it's just eyes, I cannot see any lip movement, I cannot quite hear you as well. Okay, so 2, 3, 5, 7, 11, 13, so those are the elements in the set B. Okay, then in part 2, we want to draw a Venn diagram to represent the universal set as well as the set B. Okay, by the way, when drawing the universal set, please use a ruler to draw your rectangle. Okay, so could you just spend 1 minute or less than 1 minute to draw this Venn diagram, please? Drawing the Venn diagram. Okay, so you have your universal set and the set B. Okay, so put in all the elements. We just put in the shape. Then after that, also put in the elements that are found in the universal set but not in B itself. That means in the complementary set itself. Okay, and that will be 1, 4, 6, 8, 9, 10. Okay. Then in part 3, the question wants you to actually list all the elements of B prime or the complement set. The complement set itself is a set also, although it is not represented by a circle. Okay, so from the Venn diagram, we can clearly see that these are the elements. Usually, when it comes to listing the elements, we do list it in numerical order, okay, increasing order, but actually it doesn't quite matter as well, right? You can put it in any order, that's fine, as long as the correct elements are inside. Okay, just good practice to have. Okay. In part 4, the question says, describe the set B prime in words. Okay, how would you describe B prime in words? Okay, let's think about it. Maybe one person. Use it. Yes, you use it. Okay, try to describe B prime in words, the complement set. B prime or B? We're looking at the complement set.
Prime numbers, non-prime numbers.
Non-prime numbers from 1 to 13. Okay. Alright, so let's get a thought, okay, from Hannah. Will you agree with this statement? Yes? Okay, anybody has a different thought about this? No. What if, right? Okay, I change non-prime numbers and think of it as composite numbers. Because composite and prime seems to be of opposite ideas, right? Is it actually okay if I use the word composite numbers instead of non-prime numbers? How many of you think it is okay to use composite numbers? Who thinks you cannot use composite? Okay, why cannot use composite? The girl beside just now, Vivi, yes. Sorry? Yes, okay, because of 1 itself. Okay, 1 is neither prime nor composite. So therefore, in this case, I cannot use the word composite. Okay, so I think that what Eugene has given us, okay, is sufficient, right, to describe what are the things inside B prime inverse. Okay, so they are the set of non-prime numbers. Okay. Next, part 5. Okay, to find the number of elements in the universal set B and B prime. I think that we have covered those already, so I'll just go through it quickly. The number of elements in the universal set will be 13. In B will be 6. And B prime will be 7. Okay. The question actually asked later on in BI. Okay, the question asked is the number of elements in B plus the number of elements in the complement set of B equals to the number of elements in the universal set. Okay, just by these numbers itself, we can see that 6 plus 7 does give us 13, so we will agree with this statement. But how do we go about explaining it? Okay, so how we can explain it is that since B and B prime, okay, contain all the elements of the universal set, okay, because as long as it's not B, it will have to be outside of B. They must all be inside the universal set. So the number of elements will surely add up, okay, to give us the number of elements in the universal set. So let me write that down. idea of subset. Okay, I think that we have definitely used this word before. Okay, that something is a subset of something else. So for example, okay, I have, let's say, I have the set of girls in this class. Okay, and then after that, I can have a subset of girls who are wearing spectacles. Okay, so that means it is a smaller set out of, okay, the bigger set of number of girls in the class. Okay, but then we need to distinguish properly what is the idea of proper subset and a subset. Okay, so in mathematics sometimes we want to be very, very precise. That's why, for example, we have words like less than versus less than or equals to. Okay, so in this case, if I were to consider the set A to be containing 1, 2, 3, 4 and 5, we're not considering a universal set over here. It really doesn't quite matter. It really depends on the question whether there's a universal set to be taken into account. So A does behave a bit like a universal set in this case. Then B to be the set containing 1, 2 and 3, and C to be 1, 2, 3, 4 and 5. Okay, so what we can see is that if I were to draw a Venn diagram, okay, B will be containing 1, 2, 3, 4 and 5 will be outside, okay, but still within A. What we call this is that B is a proper subset of A. Okay, whereby clearly B is a smaller set out of A. Okay, it is not exactly the same. Alright? Whereas if I want to use the word subset itself, it means that there is that possibility that the two sets could be equal. Okay, they may not exactly be equal, but there is that possibility. Okay, so when saying a case like this, whereby there's C and A, we see that C and A, they're actually equal. A bit confusing over here. Okay, they are definitely equal, but we can also describe it and say that C is a subset of A. Okay, in very loose terms that I'm saying, okay, not mathematically correct and accurate. Okay, B is smaller than A. Whereas for the idea of subset, the idea of subset could be having two scenarios. Okay, either C is smaller than A or C is equals to A. Okay, so the idea of subset is more generic. Okay, just like in comparison to the idea of less than or equals to, or more than and or equals to. Okay, whereas for proper subset, it is very specific. You know for sure, okay, that it is smaller than already. Okay. Understand? So if I want to write it in symbols, using symbols to describe this, because when it comes to mathematics, it's a lot of notation and symbols. We can see this as B as a subset of A and C as a proper subset of A. Okay? So it is like a letter C but slightly longer and flatter. Okay, so do write it properly. Okay, so this is the notation to describe proper subset. This is the notation to describe subset. Okay. Naturally, since we have notations to describe that something is a subset of something else, okay, or a proper subset, we will also have notations to describe that it is not a subset. Okay, so these are the corresponding notations to describe not a proper subset and not a subset. take a look at exercise, practice down 4A, sorry. Okay, practice down 4A, question 1. Okay, we'll very quickly draw a Venn diagram to represent the two sets C and D. Okay, how will your Venn diagram look like? How will your circles look like? Okay. I'll give you a minute to do that. That will draw your Venn diagram. When it comes to drawing your Venn diagrams, right, your circles don't have to be too neat, okay? You don't need to go and use a compass to go and draw a perfect circle. Oval will be fine as well. Okay, so yeah, just draw one round shape, okay? Will be good enough. Okay, so your Venn diagram should look something like this. I want us to see part 2 and part 3 now. Okay, so in part 2, the question asks whether D is a proper subset of C. Okay, so what do you think? Right, instead a proper subset. Section. It is a proper subset, right? Okay. Okay, so in order for us to explain, okay, when explaining, we try to stick by the definition and talk about the elements, okay, to explain rather than to try to describe the picture. Okay, describing the picture is not mathematically accurate lah. Okay, so we say that it is actually a proper subset because every element that we see that is in D is also an element of C. Okay? Because our idea of proper subset is that whatever that is in D must be an element in C. Okay? Okay, then after that in part 3, the question asks whether C is not a subset of D. Okay, so Sing, what do you think? Say what you think. Yes or no? No. So that means C is a subset of D. Yes. C is this big one, is a subset of D. Oh, yes to the statement. Okay, sorry. So, then just now she shake head, right? Okay, so, yes, alright. C is not a subset of D. Okay, and in order to explain that, we can see that the elements in C itself, okay, not all of them are found inside D. There are actually elements that are in C, that are not inside D. Therefore, C cannot be a subset of D. target about and talk about the elements. Don't talk about how the shape actually overlaps or lies within one another. Okay? Question 2. You want to see whether is it true or false. So the set 2, 5, okay, is it a proper subset of 2, 3, 5, 7? True or false? What do you think? Vanessa. Yeah. True? Okay. So yes, it is true because we see that all the elements in the set 2, 5 are actually found in the set 2, 3, 5, 7. Okay? Part B, the question asked to explain. No. Okay. So part B, 2, 3, 5, 7 is not a proper subset of 7, 5, 3, 2. Okay? What do you think? Deanna. True? True, is it? Okay. Why do you say that?
All the elements are also
okay, so therefore it cannot be a proper subset, but it can be a subset. Okay, so it can be a subset, otherwise it can also be equal. Right? Okay, if you want to be even more precise. Okay, so either we say that it's a proper subset, otherwise you can say they are equal, also fine. Okay, what about part C? 2, 5 is a subset of 5, 2. Do you agree, Matthew? True. Okay. And then the last one, part D, 2, 5 is not a it's not a subset of 2, 3, 5, 7. Zixuan, what do you think? False. So why is 2, 5 not a subset of 2, 3, 5, 7? It is not a subset. So my question is, why is it not a subset? It is a proper subset. Sorry, sometimes this kind of thing I also need to think of it. Because it is a proper. Okay, so because these elements over here are actually inside here, so therefore, okay, yes, the answer is false. Okay, it should actually be a. Okay? Is it false or true? True. This one it says it's not sorry, I'm starting confused a bit. It's not proper subset. Okay? It's not a subset. False or true? Who says true? True that it is not a subset. Who says false? If you say false, then what is it? It is a subset. Okay? So actually this question itself, okay, we see that 2, 5, okay, it is actually inside this 2, 3, 5, 7, right? Okay? It is actually perfectly fine. Okay, let's think through it first. Okay, it's perfectly fine if you want to say that 2, 5 is a subset, right? Of 2, 3, 5, 7. It's fine if you say this, right? Because for the idea of subset, okay, it could either be this or equals to. Now we're trying to see that it is actually this one here. Okay, the idea of subset is a more generic sense. right? Okay. Then, but we can clearly see that 2, 5 is actually definitely inside over here. If you want to be more precise, I can also say that it is a proper subset. Okay? So I would say that actually, in this case, you can say that it's false. You can also say that it's true. Either way seems possible. There isn't really quite a right answer to this. Because it can actually be both a proper subset or a subset. So your friend asked, is a proper subset a subset? Yes. Because proper subset falls under here one. If you are a proper subset, you can be a subset. But if you are a subset, you may not be a proper subset. You understand? I repeat myself, okay? If you are a proper subset, okay, you can be a subset. But if you are a subset, you may not be a proper subset. Because of this equal idea one. Okay? Example would be this one. Okay? So example, these two sets, they are clearly equal. Okay? This one is a subset of this one because they are equal. But is this one a proper subset of this one? It is not. Right? Okay? It is a subset because they are equal. But as long as they are equal, they cannot be proper anymore. Right? As long as if they are equal, they cannot be proper subset. But if they are proper subset, they can be subset. This one is a bigger idea. This one more narrow, more specific idea. Okay? We clear about it? A little bit confusing. Okay, so this one I will say true or false are both correct. Okay, shall we move on? Any questions? Questions? Yeah? Okay, shall we come back to question 3? Okay. Okay, I want us to work on question 3 ourselves. Okay. We turn to our textbook. This is on page 9. Okay. We'll work on question 3 yourself now. I give you about 4 minutes. If you're still a bit confused, I'll come around to help you. Okay. Because if they are equal, right, they cannot be proper subset. Give you a more realistic example. Okay, let's say we have our class setting as a 107 talking about the set of students in A1. Is it a subset or a subset? Subset, right? Because there's now that possibility that maybe two, right? Okay, now maybe address was it all? Maybe all, maybe all, maybe A1. So it can be equal, right? It can also be smaller than that. So then the number of students of A1 will be a subset. So for the it can be a proper subset lah. Yeah. But it may not be a proper subset. Because if all of you get A1, then it's equal already. Then it will be a subset. So as long as there's a possibility of it being equal, okay, then it will be a subset. Maybe if I draw an example, right, with the idea of numbers, 3 equals to 3, right? Can we say 3 is less than or equal to 3? Why not? Or equals to 3? Can I write the statement? Correct. Is it accurate to say that 3 is less than? It is an accurate statement, right? Because 3 is equal to 3. But it's also correct to say 3 is less than or equal to 5 because they're all they always it's the idea of the possibility, I mean. Then we use less than or equal to. But I cannot say 3 less than 3, right? I cannot say 3 less than 3, but 3 is definitely not less than 3. But I can say 3 less than or equal to 3. So yes, John is a parallel to a subset. Go back home, Okay, so let's look at question 3. I hope part I, when you see the elements, is not an issue. Okay, you can recognize the prime numbers as well as all the numbers in P. Okay. Now, in part 2, the question is asking whether Q is a proper subset of P or is P a proper subset of Q. Okay, option 1, Q a proper subset of P, or option 2, P a proper subset of Q. Okay, so what is the answer? Option 1, right? Okay, so Q is actually a proper subset of P, and in order to explain that, how do you explain that, Kiai? Very good. Okay, because all the elements in Q are in P. Okay, then in part 3, we want to actually list all the elements in R. I hope that isn't an issue as well. we're looking at all the positive integers not more than 13. And then in part 4, okay, part 4 asks, is P a subset of R or R a subset of P? What will your answer be? Okay, let's see. 惠佳 who's that? Okay, yes. Both can. Okay, how many of you agree with Jia that actually the answer is both can? Okay, I think I only got the 5 girls over there responding and maybe a handful here. What do you think? Jasper? Huh? You say one, the first one. Second one. Okay. Then the student stepping, Jasper. What do you think is your answer? Both, okay? So actually, it is not just this one, okay? Both are actually possible. Why? Because we notice that R and P itself, the elements are actually the same. Okay? We can say that P is a subset of R. We can also say R is a subset of P, simply because the two sets are equal in the first place. Okay? So, answer is okay. Hence, we can even go on to conclude that P is actually equals to Q. Okay. Any questions? Okay, so let's look at the last part of this section, 1.2. Yes. Oh, R. Sorry, my bad. Thank you. Okay, now let's look at the broader question of finding out what are all the subsets of a set. Let's start off with something simple. Okay, looking at the set containing the elements 1, 2. Okay, let's try to visualize this. Okay, how would we actually encompass the ideas of subset in this case? Okay, so the simple one that we're trying to do it intuitively is to consider the set S, and it can have a subset of 1 and then 2 on the outside. Right? Okay. Then we can also have maybe 2 inside and then 1 outside. Right or not? Okay? But because of the idea of subset, we know that there's a possibility that the two things are equal, the two sets are equal. So I can also have 1, 2 within inside, which is actually this idea over here. Okay? My next question to you is it okay if I draw something like that instead, whereby the set that's inside is actually empty? Okay? Yesterday when we learned about empty set, okay, empty set is a set itself. Okay? It is actually a set, so therefore an empty set, okay, is always a subset, or we can say proper subset of any set. Okay? An empty set is always a subset of any set. Okay? So subsets, we can have all the different combinations, which one is inside, which one outside and all that. Okay? We can also have the idea of the two things being exactly equal. We because we're talking about subset over here, the possibility of being equal. And then we also have an empty set. That would be a subset of S in this case. Okay? So whenever we want to identify all the subsets of a given set, okay, all the subsets would be the set containing just 1, the set containing just 2, the set containing both 1 and 2, as well as the empty set. Okay, so all and none. Okay, and then the different combinations. Right? So looking at an example, okay, let me just skip away A. Let's just already do B only. Okay, we want to list all the subsets of the set T, which has the elements A, B, and C. Okay? Can you give me one possible subset? Chloe King. Where is Chloe King? Can you give me one possible subset? Sorry? Containing A. Okay. Okay, let's choose another person. Ellipsis. Okay, tell me one possible subset. A. B, okay. Another person, Carrie. ABC, okay. And then Jovia. C. What else? Wayne. Sorry, who's Wayne again? Okay. Huh? I don't know how you say it. Sorry. A and C, thank you very much. A and C, okay. Alright. Another subset, Lavelle. Where's Lavelle? BC, okay. Davian. Who's Davian? Another subset? Or are we already done? Empty set, okay. Big Sun. This one, okay. AB, okay. Any more? Let's find out from Amelia Ng. Still right? Any more? No more. Do we agree that we stop here already? Okay. So we have the single ones. Alright. We have the S. Okay. We have everything and we have the empty set. So these are all the possible subsets. Okay. For the set T in this case. Alright. One general way for us to actually check whether we have identified all the subsets or not, we can count. Okay. To check that if, let's say, okay, this set itself has, okay, let's just do it in a generic manner first. Okay. If a set A has elements, okay, then the number of subsets will always be 2 to the power of n. Okay, so in this particular case, we find that nt is equals to 3, so we are expecting to have 2 to the power of 3, which is 8 number of subsets. Okay? exercise 1A, right? Okay, you can do it tomorrow. Okay, I don't think I may be able to come in. We see how. Okay, so if I can come in, then I will give you a longer deadline to submit this homework lah. Okay, otherwise you can save this to do it tomorrow in class. Right? If you are already done with this homework in advance, you want to take tomorrow. Okay, if I'm not in to do your own revision and all that, your own practice, by all means go ahead. So long as you don't make it difficult for the reading teacher, which I trust that you wouldn't lah. Okay. Footstep submission wise, please do this separately on separate footstep please. So exercise 1A separately from exercise 1B. Okay? Alright, so we call it a day over here. Tomorrow still please bring your stuff, okay, just in case I can come in. Then I want to continue the lesson. Can I leave my ice cream sticks safely here? Do I need to hide it? Alright, okay, so I just leave it here. If your teachers want to use, tell them they can go ahead and use it. I have no issues with the ice cream sticks. But please don't take away your own name now, okay? If you so desperately don't want to be called, just tell me privately, okay?